line is one of the procedures that we can transfer the or connect between substation and substation, either on UGC or OHTL. There is a lot of types for
Anas, come to the meeting room.
Yes, that's fine.
there is a lot of types for the structure OHTL. We have monologue, which is smaller smaller structure. We have also latest steel structure, either single beak or double beak, with the OPGW.
You are electrical or civil?
Electric.
For me, I understand there are many types of. Let's talk about lattice steel towers because they are relevant to the project. There are many types based on the angle, deviation angle, and also
Deviation of what?
deviation of the conductor.
Line.
Yes.
It's called line deviation.
Line deviation. So based on that, it's classified type A, type B, type C, type D. Light angle suspension, light angle, medium angle, heavy angle, and dead end or termination. Also, I took maybe the main components of the OHTL system. Let's say conductors, insulators, the steel structure, the pole itself, and the accessories, the dampers, and the spacer dampers, and the dampers for the vibration. Also,
Don't spacer damper do the same thing? Don't spacer damper act as vibration damper?
as what?
Doesn't spacer damper also act as vibration damper?
I'm not sure about this information. Also, I introduced myself as type of insulators. Porcelain, glass insulators.
That is material of insulator.
Materials insulators.
The type of insulator will be different, classified as cap and pin insulator.
Yeah, okay.
Long rod insulator.
Maybe the advantages of certain materials, as you said, like silicon, it has the advantage of it has some high phobicity.
Where is it used? Silicon.
Where we use it in like coastal areas.
You mean the insulator itself?
Insulators. Also,
No problem.
this is mainly general things.
That's what I want to know. Yes, please. What do you know about the OHTL?
For the transmission line. I know that we have double circuits for I think one of the project
I'm not talking about projects generally.
generally. We used to transmit power. I don't know that much of information.
No problem. So, do you know the transmission line components?
You mean the structure or theoretical?
Everything, every component.
Okay.
Can you name all the components of the transmission?
I know for the let's say theoretical. I know there is R, resistance, inductance, shunt capacitance,
I'm talking about components.
components.
What do you mean by-
Okay. Foundation. Like
Sorry,
this.
one second. Hello.
كونكتور كيكون يعني بس
إيه.
مش الكتريكال.
Conductor, insulator.
أيوة زي كده. بس اتوقع ان في اشياء زياده ما كانت.
في اشياء انا كنت شغال في بروجكت عندي خفيف
قلت لك عن الساق.
ايوه الساعه هذه كلها في البرزنتيشن، بس في اشياء كذا كنت شغال في بروجكت يعني شفت سريع كذا في تو بروجكت مع انا اندر جراوند وواحد ثاني محافظه من الاشياء فسالت كذا.
بس الساق هو يعتبر يعني موضوع في تفسير بس مش كومبوننت يعني.
ايوه صح. هذا يعني
نتكلم عن كومبوننت.
في
ايش اللي تذكرون؟ انا هذا اذكر.
انا بذكر في فاونديشن نفس الستراكشر، في فاونديشن فاونديشن، في نفس الستراكشر، في فوق الواير او بي جي دبليو عندنا ايرثينج، هذا يعزل. في انسوليتر اللي يعزل الكونكتر عن الستراكشر،
هذا انسوليتر.
وفي بوكسيه الصيانه حقت الاو بي جي دبليو تكون تحت الستراكشر.
اللي اعرف انه جي دبليو يكون مرتبط بالبرج دايركتلي لانه يمتص اللي هو ضغط اللي هو اللايت اللي هو الضغط.
اوكي، هذا من ناحيه وايد كمان يسوي عزل للستراكشر. فايبر اوبتيك
فايبر اوبتيك
يعني زي الرينج تحطها كذا خلاص ما يخلي اي مشكله، هو في اي مكان يبان يعني مشكله.
used for transmission for communication also.
اوبتيكال كمان نعرف ان في جمبر
هو اللي وين؟
من الكونكتر.
عشان نكمل في بعد التلفزيون يعني.
لا هو كيف متوصل؟ هو شوف في سلك، اوكي كونتاكت الالمنيوم هذا كيف يجي للطاقه؟ عبر جمبر، جمبر يعني مو متوصل على طول في الكيبل. ترى الكونتاكتر معزول عزل الستراكشر، معزول عزل كامل.
وصلت في
ايوه، فالجمبر هو اللي يوصل الكونتاكتر هذا اللي
صح.
ايوه. في كمان
Yes, please. Foundation.
Yes, there is foundation for the overall transmission line structure. 4 foundation, I think. OPGW cable for the earthing and communication, as well as there is like a box. I have brief. There is like a box for it will be installed to be reachable for the maintenance. I forgot what is it.
Joint.
I think joint box. Also, there is jumpers. I think to connect to transfer.
The joint box is not installed on all towers.
Okay. There is also what's called jumpers. There is spacers as well.
What is jump?
Jumpers is to connect to the conductor between the conductor and the conductor between each structure without connecting to isolate the structure.
Yeah, but this jumper will be used in which type of tower?
This one, see, there is okay. There is different angles for different stuff. If we have like angle, there is like, as you said, for the deviation of the angle.
Line division.
Yes.
Regarding the tension and suspension, why do we don't have all the tower to be tension, not suspension? Why we need suspension?
First, you answer my question.
Yes.
Regarding the component, conductor, insulator.
Spacer and also what's called for the vibration. Spacer is
Space and damper, vibration damper. Same
damper,
thing.
yeah, damper.
Also, I remember the Willie, the balloon for the.
That's only it's not permanent component. That's only temporary.
Okay.
That's
Main
not-
main components.
Insulators. This is
the most.
Yes, yes. Already I know about the transmission.
Structures are there, foundations there, and shielding wires, and joint boxes. What else?
What kind of structures? What do you
Steel
have?
structures.
What are they called? Okay, no problem. We don't have the time. Okay. Then, what are the components?
Other components would be inductor, that circle thing,
That's called insulator.
insulators, sorry, insulators, and what else?
Okay. So basically, like we said, some of the things. You have, say, two points, one substation to another substation, or from generation to substation, then substation to substation. This is over long distances, say 30, 20, 40, 50, up to say around 400 kilometers. This I discussed with you the last time. We can use AC line. Beyond this one, we use
This.
DC. If beyond this one we need to go somewhere, then we need to put one more substation in the middle. It's more expensive. Plus power losses.
Use the other one, please.
Yes, the others.
Now, how does it look like? Like, suppose you have a substation that we run. You have some GIS building, etc. All the GIS become finally to one gantry. Gantry is end structure. Gantry is a structure which is having column and beam. This is a gantry structure. This is called a gantry structure.
Column and what?
Beam.
Beam.
Gantry can be also of two types, either pole gantry or lattice. This one also some kind of. So pole gantry or lattice gantry. Lattice means just a truss system which is generally made by connecting different angles. It is lighter, more economic than pole. Similarly for tower, we have lattice. There is many views, many things. Right? We have pole. Okay. This is mainly used where you have open area. You have large space. This is cheaper. Why we need this when this is cheaper?
Flexible.
What is the right of way?
You're right to build at any certain
We have
area.
any area.
Restriction.
We have many lands belong to someone. But you have one substation here. One substation. You need to connect between them. I need to find a way how to cross this line and reach to my point. I can draw a straight line, fastest. But there is also, you have to look many roads. There is a road nearby, how to access. If this is completely straight line in the desert, how will I do? There are many factors for selecting route. You have to make analysis before. Okay, if I buy this land, does it belong to anyone? What is the price of that land? If I purchase that land, how much I have to pay? Then is there any hill, any sand dune, anything, any river, any valley, any wadi area where there is water? There are so many things. So based on that, we decide something called as the ROW, which is the okay. the right of way is narrow, yes, I cannot fit this. This is small, compact. I can fit this. If the right of way is bigger, clear?
Cheaper option.
Okay, so now how I will connect from the gantry to one tower here. If I draw a section, gantry is here. Tower is here. And then further,
This is engineer, right? For
Yeah.
AC and DC.
Oh.
Because in AC, usually require more wider area. AC,
No.
the towers.
opposite.
Isn't it?
Depends on something called as creepage distance. Creepage distance tells you what is your pollution levels, how much you are going to use current. Based on this, how much should be your insulator length, and what should be the spacing between your conductors. So based on this creepage distance, you decide the width of this cross arm, because you have to put insulator either suspension, insulator, or so now in this figure, this is a tension insulator. This is a suspension jumper. This is a tension insulator. You catch the conductor like this. What's the difference? When I have two towers, when I have two towers and I just hang this tower, hang this conductor, one insulator. This is called a suspension. It's just like I will carry this wire with my hand. Just to carry. Nothing front, nothing. It's just hanging. It's called suspension. I cannot hang for long distances. After some time, I have to catch it somewhere. Now, if I catch this wire from this side of the table to that side of the table, if nothing catching it there and here, and I hang it, after a few days, everything will come down. You understand my point? Because of its weight, nothing holding it. The complete wire, it will come down. So that holding point is a tension insulator. We'll put the conductor here, clamp it, and hold it. Once we hold it from one side, then we will pass it through suspension, mini suspension, and then we hold it. So first we hold it here, start pulling the conductor, reach here, pull the conductor, tight it as much as the tension required as per the design of the tower, and then cut it and clamp it. Then after let the conductor relax. After some time the conductor will go down and it will not go down after. When temperature go higher, conductor will go lower. When temperature go lower, conductor will go higher. Now this is called weather condition. Your weather condition for different case. So weather condition has two things. One is temperature, another one is wind speed. Alright. So you will remember everything now, right?
I'm trying to.
No, this is being recorded.
No, regardless.
Yeah.
Because after that we will make assessment for you.
No, sure.
Okay?
Okay.
After this session?
If anything isn't clear, we'll ask.
After this session or after the whole program?
You mean the questions?
After the
And then,
yeah. We can prepare one question and send it to you. You are anywhere here, right? You are coming.
Yes, yes.
You will see me, I will ask you.
sure.
Right. So we are talking about weather condition.
Yes.
We have temperature
You have weight.
and wind. In Saudi Arabia, the temperature condition vary from -1 degree Celsius to 80 degree or 90 degree. You have any question here?
In this condition, this is
Fixed
fixed.
for kingdom.
Can you repeat again?
In Saudi Arabia, we have temperature range from -1 degree to 90 degree. Why?
-1 to 90.
Yes. With the -1, maybe I can understand temperature doesn't drop below 0 here. Yes. Then why 90? Does any time temperature go up to 90?
Because we are
Air temperature.
no, the air temperature is talking about, but maybe with the conductor.
I'm talking about weather itself. Weather.
No, I don't think we're using it.
Okay, so then why do you have to consider 90?
Maybe humidity.
Safety factor.
No.
Lightning.
No. Lightning will not reach to the conductor. That's why you provide oxygen.
The current through the conductor.
Yes. What does it do?
The temperature.
High temperature.
Heat in it.
Yeah. So this is the temperature range. So when you have too much current flowing through the conductor, you decide the conductor size required based on voltage level, current level, and
Weather.
power to be transferred, distance for the power to be transferred. Yes.
Weather also.
And temperature. How much it can take. Okay. Based on that, your cross section area for the OPGW is decided. Once the cross sectional area for the OPGW is decided, you put this in software with this weather condition from -1, 25 degree everyday temperature, okay, 60 degree, 70 degree, 90 degree, 25 degree, no wind, 90 degree, medium wind, sometimes initial condition, no wind, sometimes initial condition with wind. We have different conditions. Means when temperature is there is possibility of wind. When temperature is not there is possibility of wind. So we call this, we have something called stringing. When you want to string the conductor, you should have no wind. No wind. So we have here different cases: stringing condition tension, normal tension, high wind tension, normal wind tension, broken wire tension. Okay, these are our main cases: stringing, normal wind, high wind, broken wire. Now, this we make something called as a sag and tension data. Ask this to Osama. Exactly what temperature, what sag and tension data will be
Engineer
there.
Mohab explained this.
No. You do not know about the exact numbers.
No, not exact number, but the idea they had something.
Yeah. Sag, as I told you, when you let, even if you have a conductor, when you let it relax, it will sag. So there is something called as a conductor tension capacity. Means I pull the conductor, I tie it somewhere, I pull it. After some time it will break. That is called ultimate tensile capacity of the conductor, UTS. Ultimate tensile capacity. Now, when we make tower design and when we make stringing, we will use full strength of the conductor to pull. Will we use full strength of the conductor to design the tower? Why?
Because for safety.
Okay. How much safety will keep?
I mean, you got normal safety, margin.
I will tell you. Suppose that now if you consider our line, we have around 270 kilonewton force for Jodi and 300 and 330 kilonewton for triple AC. 330 kilonewton is 33 tons. 33 tons, you pull force with 33 tons, it has so much capacity. If I design the tower using this 33 tons capacity along with all wind condition and other things, I have high values. That means when I pull it straight, my sag will be almost zero. I allow that conductor to relax. When I make the sag almost zero, it is dangerous for the tower, dangerous for the conductors. You will pull it, it may break. You have to apply too much tension, it may break. Apply too much tension, it does not have room to move. If you make it too loose, it will move too much. You need bigger right of way, it has more clashes, you need more bigger cross arm for it to not touch the structure. Many things like this. Now, based on this sag and tension data, we make a table for conductor design tension. For Jory conductor, we have used up to 21% of UTS value to design the tower and to make the line design. Means if I make it zero, my line will be like this. If I make this zero, my line will go down. I need more higher towers, more right of way, more swing, more things. If I make it tighter, my line will go up. More heavier towers. In both cases, I have problem. I cannot go too low, I cannot go too high. The standard adopted design tension for this is 21%, and for this is 80%. Now we play after this one. This is only between tower to tower. In some locations where we have gantry and tower, we make it only 5%. This is called slack span. So now this slack span is only between gantry and tower. Sometimes in some location where we have high hills, I have too much terrain like this. I have a tower. this will create for me some pulling up here. This is called uplift. And this has too much weight from both sides. More. In normal, okay, in normal scenario, we have say 2 towers, or many towers. We connect them. Okay. This tower, it has particular span where the weight of this conductor is coming on this one. It's called as a weight span. And also this is wind, so it's called as a wind span. Weight span can keep changing between tower to tower depending on the location, depending on slope. Here weight span will increase because of slope. So there will be this center line for this weight of this may come here. Sometimes center line of this conductor may come here. So the weight span for this becomes too much. But in normal scenario, usually weight span and wind span are almost equivalent. Wind span always is half of conductor here, half of
So the weight span depends on the lowest point at which.
depends on the center of gravity of the conductor where the weight will act.
So the lowest point. Let's say.
Yeah, if you have a slope area. Here, the center of gravity is here, center of gravity is here. Sometimes maybe small difference, center of gravity may be here, center of gravity may be. So small difference between weight span and wind span will be there. Clear?
So there the tower has to be bigger because more weight span. If the weight span bigger, the tower has to be bigger.
Let me know. First you understood what is weight span, wind span.
Yes.
You understood what is sag and tension.
Yes.
You understood what is lattice, non-lattice. You understood the components of the tower.
So far.
We have below the tower, we have foundation. The foundation for the tower, there can be many types. Directly we will install, we will drill a hole and put concrete, put the stuff. This is called as a
Foundation.
pile foundation.
No.
Pile or auger foundation. Yes. Okay. Sometimes no need to put the stuff inside. You can put base plate and put anchor bolt. This arrangement also is there. Besides pile and auger foundation, we also have another type of foundation. Therein we put the stuff inside and make it big like this. So this is wrong. This is called pad and tube. Further, add in pile, and then you have something called as a anchor foundation. Now I have two types of anchor foundation. I can use pad and chimney below the ground, and then I put some bar and then I fill some concrete. This is called as anchor foundation. At the same time, I can make pad and chimney, smaller one, put some bars inside, fill with concrete, then make anchor foundation. These are generally the main types of foundation steel. Foundation, how I can decide based on the tower. The tower, how I can decide
Based on the deviation angle
based on the line deviation
and the placement of the structure.
and the placement of the structure. You you ask Osama how to calculate wind and weight span, you ask Osama where to put angle tower. Suppose that you have a line like this going. Line deviation is the angle of, once this, suppose this line was supposed to go like this, but it took right turn. Okay, we are going like this. This line was supposed to go straight.
Yeah.
Now it went right. The total line deviation is this half line. Total line deviation is full angle from here to here. When you are going straight and you put here line deviation. You don't measure here, not here.
Afterwards.
Afterwards, you extend the line and then you see the angle between original line and new line. That is the line deviation. Suppose that you say, when you say a line has 90 degrees.
So we have to construct better line. Okay.
Okay, when you have a 90 degree line deviation angle, suppose please look here. You have a substation here. My line is coming like this. My original line was supposed to go like this, but my final line is going like this. What is the angle here?
90 degrees.
This is the line. Always the line deviation is measured. You extend the original line and measure the line. How the tower is placed? Half. Placement of tower will be like this.
45.
Oh,
If line deviation is 30, placement of tower
50.
except in near substation area, you come like this and you need your tower to be front of the substation without any angle, then your line deviation, then your tower will be from one side angle only. It will not make line deviation divided by 2. Okay. This is called as a terminal tower. The last tower
Before gantry,
before gantry.
Didn't.
No.
You
You call it as a terminal tower. In the middle of the line also you can use dead-end tower, and you have to use. There is difference between tension tower and dead-end tower.
okay.
What is the difference between tension tower and dead-end tower? You know suspension tower now? You are only hanging.
Yes.
Now you know other towers, 2 towers. What is that? Tension tower, dead-end tower. Tension tower is a tower where you have the line going, not hanging. No? Suspension is hanging. This hanging. This suspension. Tension tower is like this, and you have outgoing. You have incoming, you have outgoing. Mean there is some tension from here, there is some tension from here. And at every angle point you have to put a tension tower. Suspension tower will not work. It will work only maximum, sometimes designed as 0 to 4, sometimes designed as 0 to 2. Means only for straight line.
Yes.
We have more than this. You need to put a tension tower so that you can change the route of the line. In this design for suspension tower, you don't apply any tension on the tower except when this wire break, this wire will pull this tower this side. That's called broken wire. Or except before you put any conductor, you have tension tower here, you have machine here, you will pull this conductor. At the time of pulling, this has some force. That's called string. So tension tower, suspension tower has only 2 types of longitudinal loads. First of all, try to understand. You have 2 faces of the tower. This is called transverse face. and the other side, this side, is called as a longitudinal face. Transverse face,
Transverse is with the direction of the wind, right?
transverse will be the direction of the wind. Don't confuse. Okay, this is not transverse face.
The side view, right?
No, this is longitudinal face. This is transverse face. Transverse face is front view of the tower. Means what? The wind will hit like this on the conductor.
Yes.
Longitudinal face is here. That means the wind will go along with the conductor. Don't confuse between the two. Okay? Generally it happens. Transverse face is the face on which the wind will hit the conductor. Wind will hit the conductor here, pull here. Why? Because conductor is like this. And here conductor is like this. So when the wind blows like this, it doesn't hit the conductor. When the conductor is like this, when wind blows like this, it hits this transverse. So when I talk about longitudinal load, when I say transverse load, it's in this direction, on the transverse face. When I talk about longitudinal load, it's in this direction. Okay? Same face with the longitudinal face. You understand me? Suppose this is a tower. Now I say there is a transverse load. Where the load will go? Here or here?
Here.
Here. And I say there is a longitudinal load on the tower. That's good. Okay. Then we were talking about line angle and some other points related to the line angle. Tension tower. Tension tower is a tower in which we put some tension. So now in this tower I have some load this side, I have some load this side. In suspension tower I have only vertical load and only some load in transverse face, not in longitudinal face. Longitudinal face load will come only when I have two conditions. One, the wire cut, it will try to pull the tower.
Yes.
Another one, when you are pulling the conductor itself or stringing the conductor. Okay. Yeah?
Yes.
So, tension tower is a tower where you can make line deviation, and it is a tower in which you have load on the transverse face as a load. In this scenario, for tension tower, I cannot use suspension insulator. I have to use something called a tension insulator. Like this. If you see, this is a plan view from top. This is side view. Means the tower is here, transverse face, I have tension insulator here, and one back side, and then I will bring the conductor, cut it at the insulator, take the conductor, cut it at the insulator. Now, my insulator is cut from both sides. How the current will flow?
Jumper.
So I install this something called as a jumper conductor, which will be connected from one side of the conductor to other side of the conductor to flow the power. Okay. Now why I need angle tower? What is the use of angle or tension tower?
To deviate, to be able to deviate the line.
Yes.
To
Okay.
handle the load. Deviate the load.
What is the difference between tension tower and dead end tower now? I told you what is tension tower.
Tension tower, we use it for the load in transverse and longitude, and also for the line deviation.
Yeah, and the load will be, longitudinal load will be front and back. What is dead end? Same as tension tower, but load only one side.
But this is similar to terminal.
Yeah, terminal tower, dead end tower we use as terminal tower. Don't confuse. Terminal, the word terminal means last.
Okay, But it's a type of dead end.
It is a dead end. The terminal tower has to be dead end. Why? I told you, we use slack span, 5% tension. Normal span, 18%, 21% tension. So there is huge tension difference here and here. So this CRE almost zero. Means you have load only from one side. There is too much unbalanced tension here. So this tower, if I put angle tower here instead of dead end tower, this tower will fail. That's the difference between angle tower and dead end tower. You understand me? So three types: suspension, angle, or tension, and any more?
Part of the dead end
Country.
And okay, any more? Forget about DC. Tell me about DC. Any more type of tower?
Here's something else. Special type of towers.
What is it?
I saw some tower that can use to like move two lines at the same time, like 380.
Okay, that is single circuit, double circuit.
No. I mean, it's like one line is going like this and one line is going like this.
Okay, that is called as T off tower.
Yes.
Okay.
Also, we have something called transpose.
Yeah, this is what I'm looking for. Transposition tower. Where it is used?
In AC,
Why not in DC?
because no, its purpose to reduce the leakage current.
Yes.
So no leakage current in DC,
Yes.
and then hence there's no need for
At every how many kilometer you need to use a transposition tower?
in AC. Maybe I don't know,
90.
90 kilometers.
Every 90 kilometers. Confirm with Osama.
The same thing happened with the UGC to switch the cables.
Yes.
So what you do in the next one? You have transposition tower. You have tension. Here also tension. Now what I will do? I will not connect this jumper from here to here, from same phase to same phase.
Yes.
I will change the phase.
Okay. Same.
I will connect this jumper from here to the up one,
Red to yellow.
the up one to down. Like this, I will mix.
Yeah.
This is called as transposition.
Every 90 kilometer.
Transposition tower should be a dead end tower.
I have a question.
Yes.
I know UGC. I worked with UGC. I know there is sections every 500 or 600. Is this يعني every 9
500 watt, every 500 watt meter.
meters? Yes.
Uh,
So in OHTL,
Every
same
500 meter there is a section
Section.
underground cable because
Yeah.
your drum length for the underground cable
Yes.
does not come more than 500 meters
Yeah, for the joint
for the joint.
purposes. Yeah. For OHTL, 90 kilometers considered as one section.
No, not like this.
Tower to tower.
Even conductor does not come in rolls more than 300 kilometer, 400 kilometer, 500 kilometer. Sorry, 300 meter, not 300. Sorry, 5 to 10 kilometer range. Cable comes in smaller.
Yeah. 500.
Okay. Conductor comes in longer lengths. Exact length of the drum you will check with the sun.
Okay.
But you introduce, say for example now, every section tower, dead end tower, has to be installed at every 12 kilometer. That means I have span of 12 kilometer suspension tower, straight line. I go 12 kilometer. After 12 kilometer, I have to put dead end tower here, dead end tower here. This is called as a anti-cascade tower. Means suppose if this wire breaks, all the suspension will fail unless it will reach dead end tower. It will stop. This is to protect the line from complete failure. This can be adopted at different lengths for different portions from either MG, SEC, client, any third party, another country will be different section length. This depends on cost.
Isn't this considered as tension tower?
It is a dead end tower. Anti-cascading tower is a dead end tower. Even if installed at 0 degree.
Yes, this one.
Means what? When the line is coming if the line breaks in the middle, I should not lose towers for more than 12 kilometers.
Ah.
Because suspension tower has no strength in long load, in longitudinal load. So if the line breaks, the broken wire will pull the suspension tower in the longitudinal phase, and if it fails, everything will start falling, like how happened in so many places now. 5 towers fall down, 6 towers fall down, 7 towers fall down. Sometimes it stops at suspension tower. Some tower will be good. Maybe tension is less, span is less.
So
It stop, or the force jerk effect of the broken wire is small, so it stop at some tower. But sometimes it doesn't stop. So you need to put a stoppage to how much failure you want to have within the line. That's 12 kilometers. That's called as a section tower. This depends. I think 132 and 380 section tower every 12 kilometer. But if you have lower distribution lines, you have every 1 kilometer. Section tower.
Okay.
Section 4. Okay.
So can we go back to dead end just to like
Dead end is a tower with which I install the tower, I have nothing backside.
yes, this is my understanding of the
Yes, I can put the conductor and start tensioning. I don't need to have anything backside.
okay. So why we use this now between certain distance, if we are like going straight line, very long. So we're suspending the line, but as you said, for anti-cascading, we need to use this tower at 0 degrees, for example.
0 whatever degree, 90. Even
So-
if you have somewhere like you have a line like this. Suppose you put dead end tower here, you don't need to put for another 12 kilometers.
Yeah. Okay.
Huh.
So now after the tower, it will also be connected from both sides, right? We continue again. So
See, that's the specialty of dead end tower. You connect it from both sides, it will work. You connect it from one side, it will work. That's the difference between tension tower and dead end tower.
So-
Tension tower is designed for both side tension loading. Dead end tower is designed for both side tension loading and one side tension loading.
So it has the ability to withstand if something happens.
Yes.
It will hold still
Yes.
during this condition.
And you can start your stringing activities only from using dead end tower, or you need to put backstay for angle tower and start stringing. Very rare case you put backstay for suspension tower and start stringing.
Backstay.
Backstay is nothing but you have a tower, you put a guy wire, this backstay.
Just to hold it, like to resemble the
It's clear?
there's no.
Too much information?
Good.
More?
Good.
Need more or want to stop? Continue again.
As you want.
To complete the components.
To complete the components?
Yes, the dumper we.
That somehow we do. Today our topic is steel structure design.
Okay, regarding.
I didn't get there still. What is the basics of steel structure
Yeah.
design? I told you now what are the different type of towers, what should be the line parameters to be considered, what should be the sag and tension value. Now how to design the tower? What are the components of the tower itself? Main leg, bracing, cross arm, peak. What is all this? I didn't get to that still. Okay. I don't prefer more than 1 hour session.
Okay.
Yes.
I have a question. Number of towers considered in war projects according to the span and cost graph.
No, it's based on rolling span.
Rolling
Rolling span.
span. I heard from another guy. He said on the economy, the
Who decides the location of the tower? The design of the tower.
Execution.
The design of the
Yeah.
tower defines the location of the tower.
okay.
Who defines the location of the tower? Client defines. I need to
Yeah.
have rolling span like this. Now, what is rolling span? You study it now. I will tell you. Doesn't matter if the others are taking class. I will take for a few days, just 30 minutes. 30 minutes. And I will explain to you. My class is not limited only to today. I have a lot to teach you, inshallah. As long as you are here this week, next week, I can spare 30 minutes every day. Okay?
Yes.